Okay, so let me start with apologizing. I think the race for what's more preliminary is definitely going to be won by us. So I'm going to free ride from the discussant and the audience to have comments of all sorts. It's a joint work with Pamela Giustinelli that is here from Michigan. And it's really the title says it all. That's the only thing we do. We study the evolution of beliefs, and specifically belief ambiguity, during the process of high school choice. So just to quickly motivate, the first sentence has the title of the conference. So human capital is fundamental, in particular for skills mismatch and inequality. So we are right, at least in terms of the topic. First of all, we are going to study high school choice. So we have to argue that basically is starting earlier, before college, also the importance of choosing the right school or human capital accumulation. And the other key argument that is motivating this work is the fact that the choice is subject to an important degree of uncertainty. There is a lot of stuff. There are the last at least 20 years people discussed how important it is actually to take into account these aspects. In terms of uncertainty, we are moving towards the sort of subjective idea. This is how people perceive it, what actually is that people expect about the different choices, because ultimately are those that probably are determining the choice. So instead of departing from the basic paradigms, there is the rational choice decision-making that we are going to use is anyway already defining the levels of knowledge, at least at 4 levels. The first one is poor risk, like flipping the coin. This is well known, we all know it, but probably is not really what human capital accumulation is about. So there is this idea that I will call poor uncertainty, because it's still a different level, and I will argue you that 1 and 2 are very different objects. It is about things that you really don't know what are really the right probabilities about them. And there is actually another level which is now exploding, or has been exploded in the last few years, that is ambiguous uncertainty. There is a degree about the subjective uncertainty that is really lacking of assessing really the probability either, or at least single probabilities. And further, there is this limitation of knowledge. You may not know what you can choose. There are certain options that are not known to you. Okay? So those are really different levels that seems to be important for decisions. And I think education will involve all 3 in particular. And so what we are going to do in particular, we are studying how children believe about likelihood of obtaining high school diploma in regular time evolve. Okay? What are their awareness sets and what is the belief of passing all the exams? We focus on this outcome mainly because it's the closest one we can think of to the theory, but in the survey we have other outcomes.
So you can define the difference between 3 and 4 exactly?
Yes, I will. It will be really the definition. Yes. So first of all, let me say there is a growing and already vast literature on eliciting subjective beliefs, also as schooling. There is a survey by Justin Mask, but you can list dozens of, if not hundreds, of papers trying to elicit subjective beliefs. One of the things they stress in this review and other things is that it is important to elicit what people think about alternatives that are not chosen, which is one of the contributions of this project. The other thing that is important, that is relatively new in this project, although there are at least 3 or 4 papers on that we are studying learning. We are studying how these beliefs evolve. That's the stress of evolving. So there are some studies that are doing even within schooling and evolution. In our model, we have a sense in which confidence about these beliefs, and maybe we can study how this evolution might be affected by the confidence. The other thing that is really, I think, the contribution that is, to the best of our knowledge, really the first study that has this is the fact that we have a measure of ambiguity, I will define it very precisely, and in particular the evolution of it. And we can study, because now, recently, there is a paradigm that in which we can really think what would be, the rational agent learning within a context of ambiguity. Okay, so now we can look at the data with these eyes and see whether this is happening somehow. The other idea is the awareness. For example, there are studies in schooling about what you're aware of, so what are the alternatives that you can choose among, that are typically studies of static ones, not the evolution of it. In fact, again, there is a need of understanding how people change their beliefs when new awareness emerges. So we can ask, what is the paradigm for studying that? Okay? I said that's what we do. So let's clarify this. Let's start with describing the study. What is the study? Is considering all students of a certain age in Vicenza. So in particularly, Vicenza is a city close to my hometown, Verona, between 2001 and 2012. Those people are enrolled to the 8th degree, so the last year before high school. And basically, we take the data is divided in different waves. In particular, we start, so let's go. Pre-enrollment will be February 20th, 2012. So we start from October 2011, so at the beginning of the 7th, of the 8th degree, so the year before, then you will, when you finish it, you will start enrolling yourself to high school. And then another wave in December and February. And in all times, we ask questions about their beliefs and so on and so forth. I will explain what are exactly the questions. Okay. Then we have a fourth wave, because if people change their idea about this is pre-enrollment, so we want also to check whether this at the end was the true enrollment. So that's kind of things. But the three waves that we will focus around that. Okay, so like roughly for 2-3 months distance one each other. We use data close periods close to pre-enrollment, because very far people really don't even start thinking about that. So there is some hope that something is going on in that period.
So
okay.
Nicola, is that question whether you're going to go to high school or to which high school?
Which high school? I will explain in a minute. So basically at the end we get almost all the population, 10 out of 11 people participated, but Vicenza is not a big city, or not as big as Verona, at least. So at the end there are 900 people. It's not a huge number, but at least. Of them, we have a response rate of 70%. And what is the survey? It's a paper and pencil. Unfortunately, the school didn't agree on taking in school, so it's self-administered at home. But we do have, first of all, a sort of warm-up introductory study that tried to assess, and it seems that they were behaving decently, and also support for people that didn't understand, or so on and so forth, some questions possibly. Here are the things. Which one?
Who did not complete the question in the
Yeah, we are worried in the sense that there could be some, as always.
no information.
No, we do have the characteristic of them, because no, we don't know. Yeah, the population. We do have information on the whole population.
But of course, we're worried. Everyone is always worried when we do surveys. But I can say two things. One is that given that the survey is paper and pencil, I think the response rate is paper and pencil. And made home. I think that the response rate is pretty on target with that, pretty decent. The second point I want to make, but I don't have too high hopes for that, is that we were hoping to be able to link this data with the population of children based on the IB Italian system, and we would have test score for that from, say, PISA or, kind of similar test score. So I haven't been able to get schools to agree to that yet. I'm still hopeful that we'll be able to, because we do, the IDs exist and they are followed throughout all grades. So in principle, we would be able to assess it. If we are able to do that, we will be able
The inference, The inference or anything we can talk about will be always, of course, of this subgroup, so we don't know whether the whole population will behave exactly the same. I agree. I'm sorry. That sense. Okay, so how is it structured in Italy? It's like track divided, see, you know, so there are in particular, like you can group among general, so like college preparation tracks, curricula. Then there is a technical and a vocational, and we also, you know, different schools are associated with different sub-curriculum or sub-tracks of curricula. So what are the measures? The first measure is about awareness. So the question here speaks to your question. Is in particular, we ask what school or curricula do you know or have heard of? Please mark one. Okay, so they can say, I know it, I have heard the name of, I never heard about it. Okay, so that's the idea how it is. So of course, the interpretation is that I've heard is, I never heard is like, I don't know, complete unawareness. I've heard the name is basically, you are aware of existence, but you have a very, very loose idea of what's the characteristic of this. And I know is basically what you would like to receive. Yes?
Don't you think you would have gotten better participation if you wrote the survey in Italian?
Yeah, there was a fantastic. Yeah, so we should try in Italian next time. So okay, this is basically the fraction of people know, heard, and never heard. There are, you know, more than 15% never heard of, at least in wave one at the beginning. And those are just to an idea that this kind of regression are to try to understand more or less with our measure they make sense and the characteristics.
10 different tracks.
Yeah. So we did. Yes, we did tons of regressions. I didn't even know whether you wanted to see this regression because it's just preparatory. But you know. So exactly. So we did a lot of stuff with different tracks. This one is just a summary. Is a mean linear regression. We did also Poisson regressions where we just count the number of alternatives the kid is aware of. And in particular, we get a very strange result here. Apparently, if you look at it like that, that is the mom with high school degree has less amount. But if you see by different tracks, you will notice that the awareness about vocational and professional is negative, the effect, whereas for college preparation is typically positive. So it's not fully, but what I can do is a huge table, and the paper is there, of course.
So do you have a follow-up where, for the guys who actually say, yes, I know, do you know whether they know from their parents or whether...
So we have, we have exactly the same question also for the parents. We can infer, the plan is to infer what the information transmission of the parents about awareness in particular is, because it can be strategic, you know. I don't want you to go to music because I want you to go to the technical school. Yes, but for far we focus on kids, although we have information on the parents as well.
There are also a series of questions in which basically the task whom they talk to, whether they gather,
yes, exactly.
What sources of information they use to gather information, so we do have some information.
The second one is trying to elicit the point belief ambiguity, which is, so first of all, the question is, for each of the school below, there will be a list of each one, what do you think will be the chance between 0 and 100 that you would obtain passing grade or higher in all subjects and graduate on time? If you were to enroll it, of course, okay? We have other outcome, of course, but we will focus on this one. So then they have a curriculum name, they have to put the chances, and then the question is how sure you are about your number. And they can say, I'm sure about myself, my answer, then I'm not sure, then in which case they have to write min and max, you know, if they feel more comfortable. Or I have no idea of the chances, really. So that's what they're trying. So our interpretation is that when I say I have no idea, is maximal ambiguity. That's how you kind of measure this idea of ambiguity. I'm unsure is positive ambiguity, in which case we have a minimum and maximum. And when they say I'm sure, we will consider like there is really no ambiguity in their answer. So that's the interpretation we give. Yes. Also, this one is in English.
You can interpret all those in a sense of a Bayesian learner, and we don't have to talk about ambiguity or
That's the framework. A couple of slides, I will go exactly with you.
But I guess the question here is the previous table.
Sorry?
No, just a question. I mean, so the answer here, you say, I'm not sure about my chances, right?
Yes.
And I guess the question is, do they know chance? And do they know this particular curriculum? I mean, couldn't you, I don't know how important it is for framing it in a different way, a relative way. I mean, we know that doctors don't know probabilities. We know a lot of professionals.
Yeah, I know. There will be validation things, points, beliefs, seems to be.
As to the framing of that
So
particular.
I understand your question as having two parts. One is you say they may not know about that curriculum, so that's why
Correct.
we
That's a
ask
factual knowledge about the curriculum.
That's why we ask the awareness question first.
I understand.
Because we're going to be
Yes.
able to distinguish,
Right.
to check, to decompose their answers by whether they.
But I mean, I might not be able to compute a probability, but I might have a rough idea I could do pretty
Yeah.
well. So you're asking them to give a sort of, I'm not sure quite exactly what's being elicited here, that's all.
Well, this is the typical way you elicit probability. If people don't know
Give a
what.
point estimate, you know, my probability is pi divided by, you know, I don't know, some large number or something. I'm just.
So between the chance between you mean the specific phrase? This is typical in this literature again. What we can say is that these predictors of these probabilities, and we have the probability to predict choice, makes sense. Seems to be. That's the only thing I can say. What explains their beliefs and seems to make
I'm
sense.
asking a specific question about, I'm not saying it's wrong, I'm just trying to understand it. My chances of it, is it high, low? So it's just two numbers here, or what? I'm just, you know, so.
I agree. That could be that we are forcing them to answer to a number between 0 and 100. Yes, because I mean, the only thing is that we will analyze the discrete level as well.
Sorry, I'm trying to understand the question. So one part of the question was, are they aware about the thing we're asking the expectations about? And the other
No,
part
that
of
was
the
already
question
answered in the
is,
previous one. I'm talking about,
This
just
one.
are they aware of probability or their chance?
right, so.
Would I be able to
so
come
I
up
have
with a
two
subjective
answers to that
probability?
question. One is that they were given, so there were students or people who filled the survey, went to the schools, distributed the survey, and did explain how the survey worked and then put special focus on the expectations question. So they were given a warm-up example and a warm-up question in school, in the classroom, and that's the first part. The second part, what I can say is that at the end, in the last survey, I did ask a question about whether they did cover probabilities and whether they did cover percentages in.
But have you ever done a questionnaire where you actually have them calculate a probability problem? I mean, it turns out a lot of people don't know what Bayes' theorem is, even very bright.
That's not true.
That's not very
No,
important,
how could you
so
say that?
not to test
No,
it.
I'm saying that a lot of professionals don't know. There's this guy in Germany, right, Gergenieser, right? He's made a living off of this, right? Saying that basically professionals don't know and he's explaining it to them. So I'm just, high school kids might not know probability either. I mean, I don't know. Smart ones
Yeah.
might. But it's just a factual question.
Yeah.
I thought that was a big debate in the literature on elicitations, and whether or not you had, you know, precisely estimated some probability or some notion of bigger or worse or something.
There is a
Just some
growing literature
inequality,
that is
some-
eliciting expectations probabilistically and numerically, this one, and I think the evidence is mounting that these measures do have information content and are useful.
But more than just the ordinal scale, more or less. I'm just wondering how fine you can, I mean, there's a whole question about how you would interval scale this or come up with a precise number.
To have them numerical between 0 and 100 because it makes it easier. I mean, it makes it more credible to compare both within answers by the same person within person across answers and also across persons, as opposed to use a verbal space such as, you know, very likely, somewhat likely, and so on and so forth, where we don't know whether people use that.
I just think it'd be interesting to do both and get to see some comparison.
I just want to make sure I understand this and say something about Jim. So if I'm given this, I fill in the second column and the third column. Is that what I do?
Yes.
So if I obey the Savage axioms, I put a number between 0 and 100 there, and I say I'm sure about my answer. I put one number.
Yeah.
Then I obey the Savage axiom.
Yes.
There's nothing about Bayes' law, but
No, it's not.
Ah, yeah, there will be learning though.
But then if I say-
it's coming, but
okay, maybe later. But then,
Yeah.
so that's the end. So then, if I say, if I put the, actually, if I check the second and third, I might have erased the second one. Anyway.
yeah, I mean, you check you are sure. Otherwise, this chance will have to be interpreted, this number. But between the mean and the max, you write two numbers. You feel more confident about these two numbers. Yeah. I think I agree with you. There is always this limitation. The only thing I would like to say is that maybe those are, we check whether those points estimates are useful to predict choice, and they do. And we also do this sort of validation in the sense, I will basically to see where the heterogeneity in these beliefs makes sense according to observables. But that's the only thing indirect.
I was just kind of trying to use your presentation to kind of find out what the update was of this Gergenie's kind of line of work, right? He's making a fortune going around telling companies on how to do this. But he was here on the faculty 10 year ago. So I don't know, sorry, go ahead. I just think it's a strong assumption that people could actually, especially these kids, right? And it might be a function of IQ, it might be a function of their own parents' calculations. And so I don't know how you condition it, but.
Yeah, I agree. So that's the distribution. In a sense, there is some important heterogeneity. This is the quantiles, the mean. So they seem to be kind of scared a bit about the social sciences. Funny enough, these people. Okay. So here is again the sort of predictors to say, for example, the 7th grade GPA grade in all curricula seems to be strongly positively correlated with the point believed they answer. So, for example, this kind of stuff, right? Other things, I know the curriculum, I heard of, they seems to be positively correlated with that. Being female seems to be more pessimistic than males, if anything. And the general language for foreign-born seems to be, they are convinced that it's easier for them, especially if they are foreign-born. They make sense. But, not other things, they matter. So that's the other thing. Now the ambiguity dimension, first of all, the discrete one. So they have a fraction. So most of the people in this specific outcome, they are pretty sure about the answer. So, but there is a fraction, a sizable fraction that are unsure or no idea, at least in wave one. So here again, those are just predictors for the ambiguity in particular. Think number of alternative discussed thought seems to be negative related to the negative aspect, so positive related to ambiguity, negative related to ambiguity, and also the fact how much alternative they are aware. Okay, see again is a Poisson about how many alternatives they declare to be unaware, either no idea or the pooled no idea unsure. Okay, the female, if anything, seems to be more unsure than the males, if anything. So now the conceptual framework, the theory behind our interpretation of these numbers.
Isn't there a literature on overconfidence by gender?
Yeah, totally. Yeah, we don't study that, but yeah, I agree with you.
Part of the answer too. So I'm very confident in passing.
Totally.
Women maybe are less overconfident than the guy, but maybe more accurate.
Yeah, indeed, they are.
So does that affect your point estimate or how sure you are about it?
Well, it's under the estimate. You could like have
Awareness, for example, they are more aware than men.
dispersions. You don't kind of want to look at both, right? How much variability by gender and
Totally. Here, awareness, how many times I am aware of. Female are typically more aware of stuff, but they are more unsure in each other. Yeah, totally. This is what counts. So, just to convince you, I'm sure most of you already know what I'm going to.
But there are also gender differences in ambiguity, right? It's been documented, and typically women are better, at coping with ambiguity in some sense than men, right?
That I didn't know.
I have a paper.
Sorry. I should read it. Okay. I'm joking. No, I didn't know, but it's interesting. It's better in coping with that. Okay, very good. That's,
This was
In
an
the sense,
Ellsberg
in
paradox.
the sense of what? Ambiguity in the sense of
No,
what?
dealing with Ellsberg paradox kind of experiments.
they are less ambiguous than the sense of. Yeah,
That's the point.
interesting.
Oh, so you mean they're more Bayesian?
A bit closer to Savage, yes, exactly. Apparently, yeah. Interesting.
Just a fact, anyway. It's not a paper.
Okay, here just quickly, to understand why we would like to study a bit this idea of intervals ambiguity attitudes, is just to give you an example. See, consider two bets. Okay, the first one is you can bet on flipping a coin. Is the coin you brought? It's not that I'm trying to trick you. Okay, you brought from home, and if tails rises, you get $100. The other bet is there are two horses now. Yeah, you can watch them on TV. We are in a bar. Two horses there, and they are about to start a race. So you can bet which one of the two will win. Okay, and again, if horse A wins, you get 100. Now we are close to Christmas, so I give you as a present. You can bet without paying anything. Okay, which one you want as a present? You want to bet on the flipping of the coin, or you want to bet on horse A? Okay. Now consider these two bets. The first one is the same. It's again free. I'm a nice guy. You can bet on the flipping of the coin. If tails comes, you get 100. Or you can bet on horse B winning. Now, which one you want to choose? Well, it turns out that in similar kind of situations, people typically choose the bet C in both cases. It's clear now that it's difficult to reconcile this decision with unique probability of the two horses, right? So that's why kind of this even more complicated and what are typically called like Ellsberg paradoxes. You cannot explain these facts by having only one probability, even if the Savage tells you, yes, the two horses is a difficult thing, but at the end you will think through, you will come up with the probabilities. Okay? Here it says, with only one probability, it would be difficult to explain this. Okay, that's why we may want to have also another measure on top of the probability.
So you ask this question to the same person sequentially?
Yeah, I'm asking that to you sequentially. In the experiments, people do it. They have urns typically, more boring stuff. So, what is the framework? Super basic. Now, the first slide is about something that with more close to decision theories. So the idea is that we can think about states of nature. There is a set omega of state of nature, and then people have in mind the probability distribution, which can call model in mind about assessing distribution over all these states. And it would be useful to distinguish these two states between omega 1 and omega 2. The omega 1 are the one really correlated to the outcome. So in particular, omega 1 will be a list of 0 and 1s, where 0 means you fail, 1 means you pass all the exams curriculum K. Okay? So that's basically what really is about. This is something like God or nature, decides which one of the states will happen. And to make relevant for you, you have to choose a curriculum. So only when you choose curriculum K, the outcome omega 1K is relevant for your payoff. Otherwise, you don't really care what are these kind of things. So at the end, what is relevant if you choose curriculum K is this set, the set of all omega, such that the specific omega 1 in entry K is equal to 1. That's what you really would like to know. And we can read exactly the prior is exactly the probability, the measure of this set, the set C, with your model in mind. That's as simple. I mean, it's nothing new. It's just to set the evolution. Now, the reason why I distinguish between omega 1 and omega 2 is because, of course, omega 1, realization of omega 1 are only known when you get enrolled and so on and so forth, because are about what happens when you take the exams during the school. But there are omega 2 things that can happen before. So that's what we will consider this as informative signal in an abstract sense. In particular, is an example. Suppose there is a moment between the beginning of the word and before we elicit this probability of these people, that the public authority decide the curriculum, the specific program for each curriculum, the school managers decide, really create the faculty group. So you may want to know whether it's a nasty teacher, you would like to know whether there is math in it, there is computing or not in different curriculum. You would like to know all this information to assess how easy it is to go to a certain school. That's the idea. So your target is to know actually the conditional probabilities. What is my probability of passing the school knowing capital calligraphic T? This is the target. Of course, they don't know everything, but they receive, in each wave, we are going to assume that they receive information which will be sets again that allow you to assess a posterior, which is nothing more than a conditional probability of the same set, because that's the only thing you care about, conditional on knowing something. And the typical, very weak assumption in learning is that you cannot learn more than what is actually to be learned. So that's the best thing. Gradually, you get closer to capital tau. So in particular, you don't forget. You can only get closer because you can only acquire more information. This is a minimal requirement in most of the learning models. Okay, this is it.
I thought you were allowing also for the possibility that agents wouldn't know the support over which the whole distribution was defined, at least initially, right? They didn't even know what the choice, they wouldn't have a prior here, right? I'm not sure. I mean, it's a standard question, right? If it's outside the support, and you're telling them that by the first.
Those people we will be treated implicitly like I have my prior is between 0 and 100. No prior would be I actually have a range between 0 and 100. If that you want to go to that extreme, it will be like that, which is equivalent to say, I have really no idea.
But you said that the first wave, a lot of people weren't aware of these other options, like the highly educated.
Yeah,
Children of highly educated parents didn't know about vocational schools. How would they ever know? They're never even dream. I mean, I'm just asking.
So the idea for us to make sense.
Learning there, but it's not Bayesian learning. So, and you're actually teaching them, right, by your question.
Yeah, so let me say, about the awareness, if they are, we don't have in our mind a contradiction because we think that by telling them the list of schools and they have to answer, I know, I don't know, we treat them. So we actually, they know now, but maybe they have a very imprecise probability, but we make them unknown in that sense. Right? When we, at least that's the idea. Okay, here is the paradigm. We are trying to see whether the data kind of is, oh my God, very good. So ambiguity is about what? Instead of having one model, you have a set of models. Okay, so now there are 3 lunches now, in fact. Because the first one is that now you basically generate a prior, but the prior is indexed by the specific model. So now you can take the maximum and the minimum over models, in which case you get, again, for any k, the upper bound, the lower bound, and the range. The good thing is that this range is a sort of measure of ambiguity, model uncertainty, about how many models you have in mind, if you want. That's exactly used in the literature and decisions. Is exactly this difference, if you want.
Why is that a good measure? So
Well, it's a good measure.
instead of cases where the support is the real line.
The support is 0, 100, yeah. It's a good measure in the sense that the literature has models that typically say either use a minimum or use a weighted between maximum and minimum, which is basically minimum plus the range. And this number is 0 if and only if you don't have ambiguity in mind. In that sense, sorry, I didn't say good, I said measure. Okay? I mean, I agree with you. I mean, this is... But, many times when you elicit about, you want to elicit the variance, the perception, you do the minimum maximum. Here is much more reasonable, minimum maximum, because the theory tells you that seems to be actually relevant, more than just sometimes when you do variance. So, 3 lunches. Learning around ambiguity, well, you can think about very complicated things, but fortunately, Epstein and Schneider gives us that if you want to keep time consistency, which is an assumption that maybe then is not true, The good thing is that you can do model by model. So basically, you generate a new set of posteriors that is model by model Bayesian. So we don't have to learn anything new. Good, right? We like having, using vast knowledge to get new stuff. So you get the same. You get the posteriors, minimum, maximum ranges, exactly like that, because now you use the conditional model instead of the original one. The other thing is how you learn about the models, how you model learning about reducing ambiguity per se, Well, again, there is another set, here, omega 2 you can divide about learning about the alternative given the model and learning about models. So the typical assumption is that there is a set that is rich enough, so is informative enough, so that all your models that you have in mind generate the same probability distribution. Okay, this is in fact Marinacci and other people. They basically, the typical situation is, think about the example I was making. I suppose that you are watching always these two horses running. I've been watching for years these two horses race. And you now know how many times horse A wins, how many times horse B wins. You may come up, even if it's not really a flipping a coin, but you come up with the chances and you became pretty confident. This IM is basically a lot of signals about who won the race. So you start becoming, more and more confident about your probabilities. No? That's the idea. There is learning about this something like that. And of course, then when certain conditions, are met, it turns out that for any alternative, you have absolutely no ambiguity. That is, the ranges are equal to 0. So that's the spirit. Unawareness, also there is a free lunch. That's good. The free lunch is the following. What is an awareness? I don't have it. Awareness is basically, you don't know about it, but epistemically, we are going to consider the extreme version of saying, I don't know about it, and I don't know about it, and so ad infinitum. So really, no idea about this existence. If it's like that, it's fine. You can do your choice as if this does not exist, so you don't disturb it. Okay, that's an assumption about what is an awareness. The question is now, what happens if you get to know it? All this probability screws up just because you get to know new stuff or not? Well, there are axioms, Carneviero theory, that's the one you would like to see, that gives you the free lunch. That is assuming that knowledge of new alternatives don't change your risk attitudes, is an axiom. Thanks to that, for free, you get that essentially your probability distribution, if there is no change in information, of course, the probability of passing exam in the tracks that you already know, they don't change. So, of course, the new alternative, you have to assess a new probability because it was not existing, but at least the past ones can be read with the same way. Okay? So basically, don't have to worry about the other probabilities about that. Yes?
Could you just go back to the previous slide? I don't want to stop, but I don't understand that result with enough information ambiguity disappears.
It's an assumption. Learning assumption.
So that's an assumption of that the distributions are not absolutely continuous, that there are decisive events.
No. It's about the fact that there are sets in which the condition on these sets, these all probability distribution agree.
No, I don't think that's it.
Maybe it's funny. It's funny.
Because Bayes' law will keep alive. Yeah, I don't understand that.
You want this to be like an asymptotic convergence result, right?
Right.
Somehow in the
It's a convergence design. It's a limit. Tau is much coarser than IM. It's just a limit kind of aspect.
So
Tau will never be like IM. You never really have enough information to completely possibly.
Sorry.
We can come back to it because I'm going to talk about it in the
Okay.
discussion.
Okay, good.
Okay. I'm getting scared by this? Okay. Okay, so results. I'm joking. Okay, evolution of awareness. How is situation? So maybe it's not the most interesting thing in the sake of time. So here, basically, there is most of the people basically increase. There is a genuine increase in awareness. This is the comparison between wave 1 and wave 3 distribution. And there is a general increase in awareness among people, they learn something. Although the degree of, for example, across alternatives is not constant. For example, they start with the same level of, for these tracks, there is only 35% of the people that know it in wave 1, and in wave 3, there is much more, these social sciences. So they were really scared about them, but now they got to know that they.
So in wave 3, after they've seen it in the first 2 waves, they still are fractions of people who say they've never heard of it.
Exactly. That's very.
So what does that mean about learning?
They forget.
What if they're forgetting?
Yeah, exactly. Exactly. The theory seems to be, indeed, that. But when do you forget? Are you forgetting randomly, or forgetting in a sort of systematic way? Here are the transition matrices. Just an example of them. Think about wave 1, wave 2 transition among the states, no, heard, and not. Okay? So in particular, we test the difference in proportion, so they are really statistically different, these tables. Think about the no one. Okay? The first strange thing is that you know about an alternative, and in wave 1. In wave 2, you don't know. I mean, you are heard, you just decrease it. Okay? So you say, okay, maybe the standards or answering, they change across time. But why do they change so much when we are conditioning for the alternative rank bottom versus alternative that you rank first in wave 1 before starting? There is some, systematic things. You tend to forget more the one that you really don't care very much about. Okay? So that's what seems to emerge. Even more strongly for evolution of ambiguity, this seems to be happening. In particular, if you look at here, this is really sets of, these are the alternative in wave 1, and the red ones are alternative where in wave 3 you have more ambiguity than wave 1. In the sense that this proportion of being sure actually decreases, whereas the blue ones increases. So the blue ones, you became a bit more sure about your chances, a different alternative proportion of people, they kind of learn. Whereas here, they actually really less. But the question is, why really so much? We were kind of puzzled why there are certain, in particular these ones, they increase but very little. And depending on the sample you consider, here is the sample of people responding in wave 1, 2, and 3, just to have no attrition, this kind of stuff. But it's very strong, this kind of dichotomy between the general college pre-math, that is a lot of learning there, and very little in the bottom ones. Okay? So the idea here is, again, that if you look at the transition matrix for the group, what you have again that there is a fraction of people that pass from sure to no idea, or unsure to no idea. And that this is not really random, but if you look at the same transition method conditioning on between wave 1 and wave 2, conditioning on being ranked first in wave 1 or rank last or bottom in rank bottom means 4th or below, okay? Then these transitions are much more pronounced. And again, the first row is we test it is statistically different. Okay? The other one, fortunately, although is eyeball like that, the numerosity does not allow us to do is even stronger if you condition chosen. They clearly is even stronger, this distinction. So now, just to conclude, I have 1 minute. Here what we do. So I just want to advertise our measures. And I will show also you some bar graphs. So first of all, we would like to have a measure of how much information, whether there is more or less information later. So if you try to look at this dispersion of beliefs, you don't know what you are expecting, right? Because if people are heterogeneous about beliefs and they became more, they learn a lot, they concentrate more on their own beliefs. So the dispersion of beliefs is not really a measure that is good to as an aggregate. After all, we are macroeconomists. No, maybe you want to call yourself a macroeconomist. But on the other hand, the range, we'd be proud not calling yourself macroeconomist, maybe. The ranges are individuals. So even if there is a measurement error, we do have for each individual what is the range that this guy says. So at the end, we can take averages across them and try to study how these average wages across people evolve over time. Okay, that's what we are kind of do. First of all, the evolution of point beliefs here for different tracks is the first ones. They tend to increase. Okay, I don't want to. It's not super interesting. Typically, you tend to be overconfident on the chosen or the rank first, and then you go down. And the opposite if you don't rank them well, but it's meaningful. Then it's obvious in a sense. How do you get this? What is more interesting maybe is the evolution of these ranges across alternatives, as we said. So there are really heterogeneities. Certain go up and down among them. And again, if we go instead looking at conditioning on chosen versus rank first, the pattern is pretty much that rank first in wave 1, you tend to go down and then possibly up because it's not anymore super interesting for you, possible for some cases. Chosen is typically learning. Really, the ranges go unambiguously down. Bottom in wave 1 unambiguously up. Now, rank first in wave 2, typically they go down, whereas bottom wave 2, they typically go up. And those are other conditions. So the typical thing is, again, that there is much more awareness, learning in alternative that you think are salient to you, are important for your choice, and much less for... so that's it.
Are these statistically significant changes, though?
So we tested these fractions, yes, and they are statistically different, yes.
Across the wave?
Across the waves, yes, yes. We did comparison of proportions.
Over the whole set, or is there a subset? Or?
Well, the test is only, without having the problem with attrition, only on those that answer both waves.
Yeah.
Yes.
It's for all apart for a couple of them, I believe it's...
I think no, not all. I think the only one that is really not significant is this one, I guess, right?
I think it's that one and one.
Anyway, so yes, those ones are significant. This one is significant. This one, I think, is coming out non-significant. Should I put the stars? Okay. The conclusions, you can draw your own. Actually, we are welcoming any suggestions starting from yours.
Okay, so it's great to be here. Very interesting paper brought back old memories. That was also fun. So I will give a couple of concrete comments about the results, but I will mostly focus my discussion on the bigger picture of. So I think this is a very exciting project. I think this is sort of the first stage. I want to think about what would I want to see in the next stage of this search project. I think the big picture here is how should we represent these information frictions? So we have a set of people that are making choices. There's a very clear set. I thought I had 15 minutes. I was cut to 10. Okay.
Everybody.
Fine. I'll try to do what I can. Okay. We have a clear set of alternatives. We see what people think about these alternatives. We see sort of their decision. The key question is, are they making the wrong decision? Which is something that Nicola didn't talk much about. So I'm going to try to think about whether we can learn something about that and what assumptions I need to make the decision. So I'm going to strip out, obviously, as usual in a discussion, my analysis to as simple as it can get. So I'm going to have two types of high school. I'm going to call them classical and scientific. I'm going to think that people know everything about the scientific track, and everything means that they're going to have a clear probability of success there. And all the fun happens on the classical side. I'm going to have two children, Alice and Beth. What they care about is the probability of success, which is defined as finishing high school on time, and I guess passing at all intermediate levels. So as Nicola mentioned, there's going to be a set of states of nature, and I'm going to split it exactly the way he did it. So omega 1 is what you care at the end of the day, whether you're going to pass. So here I have two children, so there's both pass, both fail. Only Alice passes, only Beth passes, but of course each child cares only about her own choice. Omega 2 are things that you can potentially learn about the classical track here, which is the unknown, which you're going to learn over these waves. And so those could be characteristics like, will there be lots of math, little math? Will there be ancient Greek? The deciding factor for me, will I be stuck on drawing homework every Sunday morning, or will there be no drawing? There are no pictures in this discussion, by the way. So I'm going to make a key assumption that I'm going to come back at the end. So in order to make progress on the question, are they making mistakes or not, I'm going to have a way of assuming that some people are sort of identical ex ante. What does ex ante mean? It means they're going to have the same prior if they're Bayesian, or set of priors if they have ambiguity before the beginning of time. Then they're going to get heterogeneous information. Well, that's why potentially they're going to make different choices. And second, if I knew all the relevant characteristics omega 2, they would have the same probability of success. So that's going to be my definition of what ex ante identical means. So I'm going to observe Alice and Beth at 3 stages, and I'm going to think that they're learning over time about characteristics of omega 2. They're going to learn different aspects, so maybe one will learn about ancient Greek, the other one will learn about math. So the process, these probabilities are going to evolve in ways that we can't tell very much about. But if eventually omega 2 becomes known, they should get to the same number. Or if you think that if I had a topology on the state omega 2 and they get close to the true omega 2, then they're going to be close to each other. That's the idea. Oh, okay. I thought I sent a new set of slides, but I guess this is not the one that I had. Fine. So Alice and Beth meet Gilboa and Schmeidler here, but I really should have said Epstein and Schneider. So at this point, they're not going to have a probability distribution over this unknown state omega 2. They're going to have ranges of probability. And here what's going to be very important is they're going to have a range of beliefs about success given each omega 2. And they're going to have a range of beliefs about which omega 2 is true. And this is where Tom's question comes in. And I'm going to show you to you in a second. So essentially, what's going to be assumed here is that A and B have a range of beliefs over which omega 2 is true. But condition that they have Bayesian probabilities about the probability of success. If that's the case, then as we learn about omega 2, once the uncertainty is gone about omega 2, then we have a probability distribution. If instead the part about which you're unsure is actually success condition omega 2, then lots of stuff can happen, and convergence might be messy. And this is particularly relevant in terms of measuring the evolution of this range as a characteristic of being better informed. So I'm going to give you an example about that, because I think that's where you want to think about, that's a kind of a caveat in this story of forgetfulness. So here's a concrete example. So suppose Alice and Beth have clear idea that if Greek is not part of the curriculum, they have a 90% chance of passing. But they have no idea whatsoever what's going to happen to them if Greek is offered. Well, and then they have a prior that is precise that there's a 50% chance that Greek is part of the curriculum. And I can tell them, before they learn whether Greek is part of it, what's your probability of passing? They're going to give me a range. They're going to tell me, well, with 50% chance, the range is 0, 1. With 50% chance, it's exactly 90%. So they're going to give me a range 45 to 95%. Now I'm going to give them the information. if I tell them that Greek is not offered, they're going to go to a precise number, which is 90%, not 95. But if I tell them that Greek is offered, actually the range expands now. It goes to 0, 1. So it's not a given that this range should shrink based if you use Epstein and Schneider. If you use other things, and so things like Hansen and Sargent, for instance, you might be able to say more. Now, of course, what's true is you have people transitioning from being sure to giving you a range. That should be a measure 0 event. And so to the extent that you say that, then maybe you can talk a little bit more about forgetfulness without getting into this issue. But here, technically, just increasing the range is not a sign of forgetfulness. OK, so what can we say? Well, so I want to think about what I can identify. So suppose first, so I'm going to have many people here by a short time dimension, and people learn. So what I can do is the following. So suppose first that these people were Bayesian. Well, then one interesting question is in terms of is learning leading them to better decisions? Well, if all these people are ex-ante identical and they get sort of idiosyncratic information, the econometrician can recover the true probability out of those imperfect signals. I'm making a big assumption here that people are processing the information rationally. And then you can look at their decisions. So you're going to find, you elicit their beliefs, you see their choice. Out of that, you're going to be able to recover their preferences and tell who made a mistake ex post because they had the wrong information. Therefore, you can have a measure of the cost of information. You can say, how many more people do the right thing in the third wave? What if you have ambiguity? Well, now it's a little trickier because now you're going to have a range of beliefs. So you observe 3 ranges of beliefs, and you're going to observe a choice. You're still going to get some identification of preferences. Now it's going to be sets because you're going to have to deal with the fact that you're going to have a range of these beliefs. But you can still give bounds on the measure of people that made the wrong choice. And again, you can talk about, does this bound shrink? Does this bound move down? So fewer people make wrong choices, or more people make wrong choices? Because that's at the end of the day what we care about. So you sort of hinted, maybe people forget about irrelevant alternatives. If they're really irrelevant alternatives, who cares? But the reason you highlighted it is maybe people took a choice too early. They should have gathered more information. This is something that would allow you to talk about that. So I'm already essentially over time. So let me mention the last point I want to make. Of course, here what I've assumed is that everybody is identical. So the condition, having all the relevant information, they would make the same choice. Obviously, that's not the case. So in practice, you're going to have to deal with the fact that people are different, and therefore that's why we have different tracks. And so you're going to have to repeat the experiment, trying to match them over observable characteristics, maybe, or impose some monotonicity restrictions. Say, well, there's tracks that are better suited for GPA, so therefore I'm going to look and cross-correlate the GPA with the awareness and try to get at whether they're making right choices based on additional assumptions that you're going to have to do. And that's all I have.
Thank you.
Okay, yeah, that's the kind of rewriting I was hoping to get. This kind of thing, I thought about exactly this kind of stuff, and indeed some assumptions, especially when you have an empirical person as a concept, some assumptions of homogeneity are difficult to argue for, because there are many dimensional heterogeneity, but I agree with you that at least in terms of modeling and see whether this model fits decently well, I can do this computation, and actually Thank you very much, especially for ambiguity, telling me that there are these bounds. I think I will definitely try to go that route. Thank you very much. Yes?
A lot of the empirical literature doing something, looking at these subjective beliefs, typically it ignores the ambiguity and awareness issue. It might be interesting to sort of compare the, in some way the approach that would be taken if you followed what most people are doing versus when you somehow take into account ambiguity and awareness and how that changes, either how we think beliefs are evolving or how choices would be made. How much, in the end, how important is it to take these into account, or what types of cases is it particularly important, and what types is it not, to kind of inform the rest of this literature that isn't doing it?
Yeah. So, strictly speaking, I mean, again, there we didn't try to present a full choice model, precisely because we are arguing about this perverse way of, and in particular, I didn't have time to do discussion, but that's the idea, the fact that people can get stuck there. These measures are more quantitative, whereas the arguments are that I was trying to make are more qualitative, but that's exactly the way. So the ambitious project would be to write a model of how people learn and systemate jointly these two. Okay, that was at least to be consistent with what we think is going on. And displaying example that you can get stuck and this kind of stuff are not difficult to get. What was difficult that I didn't think about was some regularity assumption. Can I say something instead of just examples? And in which case I will take assumptions, maybe model these kind of things and see some. Yeah, that's. Yes.
Can I ask about the environment in which these children are answering? These are multiple waves.
Yes.
So maybe on the first wave you think I introduced this possibility to them. Now meanwhile, the target at which they're learning about may be changing, right? And schools may open or close, teachers may be fired. But more importantly, I would think there would be a lot of knowledge from other students. So the question is, what do they learn? I mean, the mechanism of learning, I wonder how you can control for that. There'd be certain peers. So people who are interested in Greek would maybe hang out together. The Greek geeks, whatever. And so in that sense, I just wonder in your survey, are you able to allow for this kind of peer or somehow this formation of learning from looking around and just experiencing it? So I suddenly learn that there's vocational training. So maybe I suddenly hang out over at the school and learn. It's great. I can run a lathe. So I just wonder how the survey can adjust for that, whether you can. I'm not saying you have to do it or anything, but I'm just...
We have a battery of questions at each wave in which I ask them to report what they talked about with different sets of people. Like, say, for example, did they talk about what schools they talked about, what types of school they talked about with, say, their parents, with their peers, with their friends, with teachers or experts.
So does that reduce or contribute to ambiguity? Because you have 100 voices and things become more noisy, right?
So yes, there is a.
There's this old paper by Raj Shah in the JPE, which is all about that social learning, and whether it makes it more correct or more incorrect.
Yeah.
So yes, Snyder and Epstein there is what the model I was presenting is implicitly saying there is only one likelihood. So they say there could be a set of likes, so you can add ambiguity by learning. We rule out, we didn't take this route because in fact there was not a lot of institutional change and this kind of stuff. In that sense, one minimal restriction we took in that sense. But still, even in that case, even without any additional ambiguity coming in, without further assumptions, apparently, you can get anything. Yeah, we are aware of that. Yeah, I agree. So I don't know a better measure of seeing whether these people are learning, in a sense, right?
Well, peers. I don't know if ideally you could imagine if they're networks and they hang out together, you'd think those networks might converge in some sense, but then you might switch networks if you really got interested in another topic. I mean, I realize that's not what you have here, but it would just be possible, I guess. Right?
Yeah.